Today, I'm going to cover SpaceX's plans for launching 1 million AI compute satellites into orbit. While SpaceX is not a startup, such an enormous amount of satellites placed into orbit will reshape the space sector and the orbital economy. It's likely other companies such as Blue Origin, Google, OpenAI, and others will follow suit, especially if, as Elon Musk has stated, within at most 36 months, orbital AI will be the cheapest way of building data centers. For decades, people have speculated what is a killer app for space. By that, they mean what is the one product or service that everyone has to have. If that turns out to be orbiting data centers, the entire space sector and orbital economy will expand massively as hundreds of billions of dollars will pour into space, rocket companies, and satellite manufacturers. Space startups could benefit directly, or, as second-order effects kick in, benefiting from space becoming cheaper because of the massive scale of launches and satellite manufacturing that would occur. We know companies like Relativity Space received investment because of interest in orbital data centers, and OpenAI CEO Sam Altman considered buying Stoke Space in 2025. So, first let's look at the application for launch authority for the SpaceX Orbital Data Center system that has just been filed with the FCC and which the FCC has just now accepted. Then we will look at the plausibility of orbiting data centers becoming the cheapest option in the near future, followed by the implications for space startups. The filing. On the 30th of January 2026, SpaceX filed a request with the FCC to launch and operate a constellation of up to 1 million satellites as orbital data centers to match the growing demand for AI computing power. The idea is that these orbiting satellites will use the free power from the sun and the free cooling of the vacuum of space and the unlimited scaling possibilities of space to build bigger and cheaper data centers than can be built on Earth. The energy efficiency of solar power in space is about 5 times that on Earth. Most solar farms produce 20 to 25% of their nameplate capacity due to 2 factors. First, no energy is produced at night, and second, clouds, rain, dust, and low sun angle cause losses. So, in space, solar power is about 4 to 8 times more efficient in terms of energy collected per solar panel than on Earth. Turning to cost efficiency, solar panels on Earth are normally fitted with batteries to store collected energy to sell to the grid at peak times. This is a major cost for solar farms, often doubling or tripling the cost of solar power. No batteries are needed in space as sunlight is uninterrupted 99% of the time for dusk-dawn sun-synchronous orbits, dramatically undercutting solar power expenses in comparison to Earth. The vacuum of space acts as a giant heat sink with a temperature at minus 270 degrees Celsius. Add to that no paperwork or bureaucracy that's needed for Earth-based data centers, and orbiting data centers look appealing. Elon Musk has stated the design for the AI satellite will be based on the Starlink version 3 design. Strip out the phased array antennas and scale the power from 20 kilowatts to 100 kilowatts. Add some radiators for cooling, and you have an AI satellite. Elon Musk has stated an AI satellite is easier, not harder, than the Starlink version 3 design. Starlink V3 should be launching at scale, according to Elon Musk, by the 4th quarter of 2026. The AI satellites will communicate with Starlink using the same optical lasers SpaceX uses on existing Starlink satellites. The fleet of satellites will be located at altitude range from 500 kilometers up to 2,000 kilometers, with inclinations around 30 degrees. The orbits will be sun-synchronous to maximize solar exposure. The document is just for authorization, so no details on deployment timelines are given. Elon Musk has stated that within 36 months at most, and maybe only 30 months, space will be the most cost-efficient and energy-efficient location for data centers. In the filing, SpaceX revealed they plan to launch up to 1 million satellites to operate within narrow orbital shells with a thickness of no more than 50 kilometers. This leaves enough room to deconflict against comparable systems from competitors. SpaceX's plan includes launching 1 million tons per year of satellites generating 100 kilowatts of compute power per ton, resulting in 100 gigawatts of AI compute capacity added annually. It's likely each satellite will be 2 tons or more in mass, so each satellite will likely generate 200 kilowatts of power, comparable to StarCloud's future 200 kilowatt inference node satellites recently announced. One point to emphasize is that AI data centers have two main tasks. First, training an AI model, and second, running inference, which is a technical way of saying running queries against an already trained model. These satellite systems from both SpaceX and StarCloud will be for AI inference. In other words, orbiting data centers will be used, at least initially, for scaling the queries of existing models, not for training new models. Orbiting data centers can train models, but they are less suited for this task because of the enormous memory and very low latency needed in training. Okay, let's consider if the reason for placing data centers in space holds up to scrutiny. Is space the best location for data centers? It's simpler in terms of paperwork and compliance to build a data center in space than on Earth. People are upset with increasing electricity prices and don't support data centers in their communities. This often leads to protests and environmental reviews that add years and millions of dollars in costs to a new data center. Powering data centers on Earth is another huge problem. It's not just new power plants that need to be constructed, it's the purchasing of critical components like high voltage power transformers, plus the transmission lines needed to route electricity to the data center. High voltage transformers, for instance, face severe supply challenges with long lead times already. That's before the rush to build data centers. Typical lead times for a large power transformer is 2 to 4 years. In the US, imports account for 80% of demand. Building new transmission lines in the US can often take 5 to 10 years and face opposition from locals. Interconnection queues in high demand areas like Texas will likely result in no new transmission lines until the 2030s. Power grids are not designed for rapid expansion and could result in grid instability or even, in the worst case, failure. Elon Musk has flagged transformers as a major near-term bottleneck. It is worth noting that 25 to 40% of the ultra-high voltage transformers needed for power stations come from South Korea. President Trump recently increased tariffs on this country to 25%, which could lead to increased costs to US customers. Orbital data centers are immune to geopolitics and tariffs. It isn't necessary for space data centers to be the cheapest method immediately, they simply need to be cash flow positive. Starship should be operational with an enormous capacity to launch mass into orbit, like Falcon 9 launching Starlink when commercial payloads are not available. SpaceX aims eventually to launch Starship every day, or perhaps many times a day, putting AI satellites into orbit when not carrying customer payloads. With exceptional low internal costs for SpaceX, since Starship is a 100% reusable system, it's profitable as long as propellant and operational costs are covered. With XI now a part of SpaceX, the cost per launch is the internal cost to SpaceX, not the price, reducing launch costs far below what competitors will have to pay. Challenges with orbiting data centers. Some negatives to consider are maintenance of the satellites will not be possible, at least with the first versions. Perhaps in time, modular components that fail can be replaced using robotic systems. Latency at around 20 to 50 milliseconds is higher than terrestrial fiber, but probably not noticeable in most cases. A higher radiation environment will cause bit flips, which could degrade the results or potentially cause software errors. Elon Musk has stated that neural networks are inherently noisy as they contain trillions of parameters. If one of these parameters gets flipped by a proton, it doesn't really matter. For more crucial software, triple redundancy systems, which are common for space systems, should resolve that. Heat dissipation is another concern. The GPU cluster runs hot. That's why so much water cooling is required for Earth-based data centers. In space, passive cooling is used, but it requires large radiators, which increase the mass of satellites and therefore launch costs. The solution is to run the GPUs as hot as possible, as radiator area is strongly affected by the temperature. Elon Musk has stated just increasing the chip's operating temperature by 20 degrees Kelvin will roughly half the size of the radiator area needed. The cost is another concern. No matter how cost or energy efficient orbiting data centers are, they cost a lot to launch, especially if you don't own a rocket company. How will orbiting data centers benefit space startups? 1 million tons launched to deploy one orbiting data center suggests a massive increase in launch cadence and capacity. Other tech companies are looking to launch competing data centers in space, such as Google's Suncatcher project. While SpaceX can use Starship, other tech companies will need to buy and launch on the open market, and perhaps purchase satellite buses and components from space startups or established companies. For those space startups not involved in the initial build-out of the AI constellations, the massive increase in capital spending on space will have second and third order effects, such as lowering launch and manufacturing costs that should benefit their business. For instance, startups working on in-space operations, such as robotics, space tugs, refueling missions, or commercial space stations, may see benefits to their businesses, as these giant constellations may need services for constellation management, such as disposing, refueling, life extension, repair, or upgrade. Final thoughts. Perhaps orbital data centers will be the killer app, or the one essential service that will force the tech giants to spend hundreds of billions of dollars on space operations that would otherwise be spent on Earth. What do you think of Elon Musk's plans for 1 million AI satellites in orbit? Is this a good thing for space startups and the orbital economy? Leave your thoughts and opinions in the comments section below. Thanks for watching. If you enjoyed this space video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Space News Live is on Saturday evening or Sunday morning, depending where you watch from. The live stream is a great way for you to share your thoughts and opinions on the videos I posted this week, or on any space topic in general. I highlight the most thought-provoking comments on videos I've received, along with previews of upcoming content. If you got the time, please tune in and say hi. Be sure to like and subscribe so you'll see our upcoming videos. We make videos every week covering the space industry, with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.